Good morning to everyone. In today's lecture, we'll discuss about the resource allocation. Resource allocation is coming under our resource management in cloud computing. So here, basically, we have a set of requirement that is given by a set of users, and you have to allocate resources to those users based upon their requirement. Right? That is the main goal behind resource management and resource allocation. In fact, the resource is managed by your cloud service provider, and resources are asked by the cloud user. Right. So here we will see a set of algorithms so that you will know that how actually the resource allocation takes place in cloud computing. Right. So, in order to go for this topic, another topic is also we are going to discuss, that is called as task scheduling. So, these two topics are used interchangeably: resource allocation and task scheduling. Okay, just a minute. Okay, so there is another topic that we'll discuss, that is also called as task scheduling. So if you go through research articles and various web pages, you will find resource allocation and task scheduling. They are used interchangeably. Okay, they are used alternatively, but there is a difference between resource allocation and task scheduling. Like also you can see in your mid paper, I asked you about elasticity as well as scalability, right? Although the dictionary meaning of these two words are similar, but they are different based upon the automation level, right? So whenever you are requesting some resources in the cloud, your provider is allocating the resources to you. Like we have seen about Amazon EC2. In Amazon EC2, you can choose a particular instances, or if you need a set of instances, right, of the same configurations also, you can request to the cloud service provider. Suppose let us consider a web application, right? For the web application, suppose you need 10 different instances. Uh, let's say the instance is t2.large, right? So once you request a t2.large instance, 10 different instances to your cloud service provider, your cloud service provider is going to alert 10 different instances, maybe in the same region or in the different region, right? Now, once you get these 10 different instances, you have to decide that how to manage traffic if it is a web applications, or you can think about how to allot a particular, how to manage the different modules related to web applications. And you can also think about in what order you are going to process the request. So when these things are come into picture, we call that as a task scheduling problem, right? So there is a difference between the resource allocation and task scheduling. So once the resource allocation is done, then only you can proceed towards the task scheduling, right? So first thing you need to understand about the resource allocations. Then ordering you can find through the task scheduling algorithms. So in order to illustrate different kind of requirements, and in order to discuss about different algorithms, so we have to take some assumption, right? For example, here you can see I have taken a 4-node cluster, right? Just imagine in your computer lab, you have four different computers, and they are connected to each other, right? Or one computer is the master node, another three node are the slave node. Okay. Uh, they are connected to each other so that they can provide resources to the customer. So here the x-axis represents the time. For example, I can say the time is 10 a.m. here and 10:15 a.m. here. Similarly, I can say here 10:30 a.m. here. Like that, it is a period of time, right? Similarly, if you look into the y-axis is nothing but the number of nodes. Okay. Although if you go for master and slave architecture, master has more powerful in comparison to slave. So if you look into such architecture, uh, master is actually coordinating the request, and finally it is assigned to the slave to execute it. But in this cluster, all the nodes are equally capable, right? They are equally capable. Suppose you will ask one node from this four node cluster, then node 1 can fulfill your requirement, node 2 can also fulfill your requirement, like that node 3 and 4 can also fulfill your requirement. So whenever a customer gives you some requirement, we call that requirement as lease, right? So the term lease is nothing but, so it is just like a formal requirement, right? There is also a contract between the customer and the provider. Everything is written in the form of a lease. Like we have seen service level agreement, what are the parameters we have in the service level agreement. Similarly, lease is a formal document, right? Where the details of the different requirements or details of the type of services the cloud service provider has to provide, that is mentioned in that document, right? Or that e-document, you can say it is a e-document only, right? So we will see that how to assign a set of leases submitted by different users to this four node cluster. So obviously, if there are four nodes are available in the cluster, if somebody is asking five nodes, then you cannot fulfill that requirement, right? Because your that is beyond your capacity. But if somebody is asking about three node, you can provide three different node out of these four nodes. But sometimes if a user has submitted a lease and the requirement is for three nodes, then also you cannot provide it due to the resource unavailability. For example, I'll say you, for example, 10 a.m. to 10:30 a.m. one lease has occupied three different leases. One lease has occupied three different nodes. So let's say one request reaches to you at 10:20 as a cloud service provider. It is asking you two nodes. So two nodes is practically not possible because at 10:20, three nodes are occupied by a lease, right? So it has to wait up to 10:30 in order to get two different nodes. That's why these leases are coming over the period of time. You have to look into service availability. You have to look into how many nodes are available, and based upon that, you can take a decision that whether to accept that lease or to reject the lease. And in fact, the resource allocation algorithms are required to resource allocation algorithms are required to properly assign these leases into the different nodes so that the maximum number of leases can be accepted. Okay, and minimum number of leases can be rejected, right? That is a necessity of an algorithm in this particular topic. That's why various researchers have proposed different resource allocation algorithms, right? So we'll see how actually what kind of leases they are submitting and how to alert such leases into different nodes, right? So throughout this presentation, you will see we have taken a 4-node cluster. Sometimes we have taken a 5-node cluster. Okay, and we assign different type of leases, or sometimes we assign only a set of leases of the same type to this 4-node cluster. So our overall objective is to, we want to the lease parts of that cluster over the period of time. So let us discuss what are the different type of leases or different type of requirements a user can submit to the cloud service provider. The first one, first type of lease is called as advance reservation. Like whenever we travel to a particular place, we go for advance reservations, right? We book a train, we book flights, right? In which we have a specified start time and a specified end time, right? Like you board a particular train at 10 a.m., you are expected to reach by, let's say, 5 p.m. So you know that this is the duration from the source to destination. So similarly, when you go for advanced reservation lease, you will see advanced reservation lease is a lease that must begin and end at a very specific time. Begin is the start time, and means it is the finish time, right? So, for example, if you look into this AR lease has the begin time is 1 p.m. or 13 hours, and end time is 14 hours. So it is already fixed. So within this period of time, you require how many nodes here? You require three different nodes. Three nodes out of the four nodes available in the cluster. So if the resource is not preoccupied by other leases, then you can assign three nodes to this particular lease. Okay, but in between 13 to 13 hours to the 14 hours, if a lease is arrived at this particular period of time and it is asking more than one node, I can say greater than one node, then it is practically not possible, right? If it is greater than one node, the maximum available node in between 13 hours to 14 hours is only one node. So if any requirement is coming which is more than one node, simply you have to reject it, right? You can only accept one node in between 13 to 14 hours. So if you go for mathematical representation of, these leases, then we have taken here a 4 tuple, like you studied mathematical modeling of different machines in theory of computation. So there also we consider a set of tuples, right? So here we consider a 4 tuple, like if a advanced reservation lease, I can represent as AI, which is equal to SENT, okay? Where S is nothing but the start time, and E is nothing but the execution time. So for a AR lease, you need either the start time and the end time, or if you know the start time and if you know the execution time, right? If you know the start time and if you know the execution time and if you add it, then you will get end time. So out of these three parameters, you need any two parameters, right? Either the start time or end time, or start time, the execution time. By adding these two, you can get the end time. So here it is given as execution time of that particular lead. N is nothing but your number of nodes. You need some specific requirement, right? How many nodes are required to complete that lead, right? And the last parameter T is nothing but the execution type. So there are two type of execution in advanced reservation. In any type, if you see all the leases, they are categorized into two type of execution. Either they are primitive, or they are non-primitive. And you know what is the difference between primitive and non-primitive? Can anybody tell what is the difference between primitive type and non-primitive type? You've studied in operating system. What is the difference between primitive and non-primitive type? Yeah, anyone? Difference between primitive type and non-primitive type. Primitive means,
It is predefined, and for the non-primitive, the user used to define it.
no, it's fine. But primitive means while you are executing your request can be preempted. Preempted means it can be stopped and it can be resumed in later point of time. Non-primitive means once you start your work, then once you complete it, then only you can release the resources, right? In between, if any high priority request is coming into picture, still you are not going to release it, right? This is the basic difference between primitive and non-primitive. One of the example you can see here, like if I take this particular example, I have started the lease at 13 hours, right, or 1 p.m., right, and it has to continue for 1 hour, and it need to complete by 14, right? But let's say there is another lease which pays more to the cloud service provider, or you can say that particular lease is much more important in comparison to this particular lease. It has arrived at let's say 13:20, and you want to print this AR lease, right? You want to stop this particular AR lease. But if it is in non-primitive mode, okay, then you cannot stop it, right? You can get the resources only after 14 hours if it is in non-primitive mode. But if it is in primitive mode, then what happens? You can print this list at 13:20. You can give the resources to other leads. Let's say that other lead is completed at 13:50, right? With a 30-minute time span, then you can resume this particular lead, right? For example, this lead require another 40 minutes, so I can start at 13:50 and I can continue 40 minutes up to 14:30, right? So that is called as your execution time. Whether it is a primitive means you can stop and resume later point of time. Non-primitive means you cannot stop it in between its execution, even if you have a high priority uh, job, okay, or high priority leads. So these are the four different parts that you need to define if you want to define a advanced reservation lease, that is AI. And as I already mentioned, the execution time ET, okay, the sum of execution, the end time of the sorry, ET is your end time here. End time, let's say this is EET. ET, in order to find the execution time, you need to add the start time and E. Okay, let us represent it by E to avoid the confusion. Okay, so start time plus end time, that is E, is equal to your end time, that is ET. So if I ask you to represent this advanced reservation list in this tuple format, then you can say advanced reservation list 1, let it be the ID 1, then S is nothing but 13 hours, then E is nothing but the 14 hours, number of node is 3, and T is primitive, T is non-primitive, so it is non-primitive. Let's say for or 1, and either way, right? So as it is non-primitive, I am representing 0. Primitive means I will represent it 1. So the release is going to be submitted in this particular format, right? If it is an advanced reservation lease, right? And in fact, advanced reservation lease is having more priority over other type of leases because it is a specific start time and end time. Okay, but if you go for other type of leads, you will get a little bit more flexible system, right? Flexible type, right? But this is a rigid system, right? It need to start at 13. If your resource is not available at 13, let's say it is available at 13:01, okay, 13 hour 1 minute, then also this lease is going to be rejected. You cannot delay advance reservation lease for 1 minute of time also, right? So due to rigid structure of advanced reservation lease, you can say most of the AR leases are rejected, or it need to be pre-booked, or it need to be reserved over reserved before you can say before a couple of hours, right? So that it will not reject, or a couple of days, so that it is not going to be rejected. So the next type of lease, and the second type of lease, that is called as permittable best effort lease. So generally, the best effort lease is much more flexible in comparison to advanced reservation lease, because you can see sometimes we know that we need resources, but we don't need to them at a specific time. Suppose one assignment is given to you, and if I ask you to complete it by Sunday midnight, then you will see your flexible time, right? Suppose you are free on Thursday, then you can decide I'll complete this assignment on Thursday. Somebody has a busy schedule on Thursday, he or she can plan on Friday. Okay, another person can plan in the Sunday morning, right? So we need the resources, but we don't need in at a particular specific time. And if you look into our example, that is, if you want to travel somewhere, but you have not booked the ticket, then you are taking a simple ticket, right? Or you can say general reservation, sorry, general ticket instead of a reserved ticket, and you can travel in any train of the respective category, right? So in fact, we are perfectly content to wait until there are enough resource available for our needs. So if you go for this cloud computing term or resource allocation term, we don't want to specify a particular time, because we know that in that specific, if you specify a particular time, your lease may be rejected, right? So we are giving much more flexibility to the cloud service provider to execute our lease, right? We specify our requirement, but we have not specified what is the start time and what is the end time, right? So whenever the resources are available, or you can see here, as soon as the resources become available, then the cloud service provider is going to provide you the resources. So when we request the best effort list, our requests are placed generally in a queue. Okay, so we are maintaining a queue. In that queue, we are putting one by one best effort list, right? So, for example, at a particular period of time, you have you got let's say two best effort requests. Then you can say, let's say this is best effort one and this is best effort two. So we put in a particular queue, right? In first serve basis. Obviously, queue is also always first in first serve basis, and we are going to execute B1 first. Then only we can go for B2 first. But the problem is that suppose BE1, as I already mentioned, it is permittable. Permittable means it can be stopped at any point of time. So if B1 is preempted from the system or stopped from the system before it has completed its execution, then it will be put in another queue. Okay, let's say I'm saying queue days, and until unless that particular lease is resumed, you cannot start another BE lease, right? For example, you can see B1 require, let's say 2 hour time. Okay, B 2 hours, and B1 requires, let's say 30 minutes. 30 minutes, right? So after 1 hour of execution of best effort one leads, B1 is preempted because a high priority lead is arrived to the system. So B1 is preempted. So B1 is left with 1 hour, right? So until unless B1 completed this 1 hour, you cannot start B2, right? Another important thing you can note down also here, like if a B1, suppose B1 leads is printed from, let's say, node X, then it has to again resume another 1 hour in the same node, not in any other node. Okay. Even if the resources are available in other nodes like node Y or node Z or any node, it is not going to execute because it has partially executed in a particular node, right? That's why we maintain two queues. You can say one queue to place all B leases Another queue is to place a, you can say, uh, the printed leases into the queue days. Okay, so that we can resume it. Now, as we have discussed about two different type of leases, and these two leases are in fact used by different cloud service provider. Okay, so we should know that what is the priority, how actually priority works in AR lease and BE lease. So AR lease has more priority over the best effort lease. Hence, it can print the BE task on its arrival. Okay, so AR has more priority. This is your advanced reservation list. It has more priority over this best effort list, right? Because why it is more priority? Because AR has specific start time. AR case, you have specific start time and specific end time, or you can say specific duration, execution time, I can say, right? But best effort case, you are given with the execution time without any specific start time and end time. Okay, so that's why you can say AR leads is more costly also in comparison to the best effort leads, and AR leads has more priority also over the best. If somebody is having more priority, then definitely he has to pay more. Okay, hence it can be print the B task on its arrival. Like here you can see a B task starts execution, let's say at 10 a.m. Okay, and it is asking resources up to let's say 11 a.m. But at 10:30 a.m. a advanced registration lease is arrived to the system. So a B lease which is low priority, it is printed and it has given chance to the AR lease. Let's say the AR lease has completed its execution at 11:30 a.m. Right? Then the printed best effort lease is again resumed at 11:30 a.m. and it will complete at let's say 12 noon. Right? So it is expected to complete when it starts at 10 a.m. We expect that it is going to complete at 11 a.m. Right? Because it requires only 1 hour duration. But as AR lease is arrived in between, so and it has more priority, so the best effort lease is printed and it is rescheduled to the same node. Okay, whenever the resources becomes available. Like the resource is available at this particular period of time, so it is again resumed. However, if a AR lease is executing, like you can see here 10:30 to 11:30, a AR lease is executing. Assume that another AR lease arrived at 11 a.m. Right? Now there is a competition between AR versus AR, right? So a AR lease cannot print another advanced reservation lease. Okay. So obviously the second AR request is going to be rejected if it is requested at 11 a.m. Okay. Similarly, if a best effort task is executing or lease is executing, then another best effort lease arrived, then it cannot print that best effort lease. Right? B also cannot print B. So as there is no specific time, so it has to be put in the queue, and it will be solved in FCFS order. Right? Once this B is completed, we can start the next best effort. Okay. However, when there is a B AR into picture, right? A B is executing and AR is coming, like this particular case, then B leaks is printed and AR is given chance. On the other hand, if you see an AR lease is executing and B is coming into the picture, then AR has more priority. So B will not given chance. Okay, B has to wait. So the question and the main, you can say overally or in summary, you can say a best effort lease can wait, but if AR request cannot be put in wait, right? It has to be simply accepted or it has to be rejected, right? Like here you can see like AR is rejected, second AR is rejected because they have specific start time. So if resources is available, you can provide it. If resource is not available, simply you have to reject it. There is no other choice. However, same type of leads, BB or you can say AR, they cannot print each other. Okay, so most of the cases you can see B leases are rejected, AR leases are accepted because AR leases specific start time. Right, it has more priority. So sometimes if there is a frequent arrival of AR happen in the system, then the B leases are frequently rejected, which is not good. Right. So if B leases are there in the system and continuously you are getting AR, the first priority will give to AR. Okay, once AR is done, then only you can think about B. So it may also leads to starvation. I studied in operating system what is starvation, right? The same thing happened here. So unsatisfied, they are not satisfied. The B customers are not satisfied. So in order to avoid that, there is another type of leads introduced that is called as non-primitive based effort. Okay. So you have seen primitive based effort, right? But here it is non-primitive based effort. The only difference is that once a B lease has started its execution, it is not going to be interrupted in between. Once it is completed, only the resource is going to be released. So a non-primitive based effort lease is a kind of lease that does not allow to preempt the based effort lease intermittently on arrival of higher priority lease. For example, you can see a based effort lease arrived to the system at 6 a.m. and it is asking for 1 hour. Okay, and the number of node requirement is 4. Okay, it is mode is 0 means it is non-primitive. But let's say 6 a.m. To 9 a.m. the resources are busy. All the 5 nodes are busy. Okay, or you can say it is asking 4 nodes, so 4 nodes are not available. So what happened? 9 a.m. Let's say the resources are available. So we have started non-primitive based effort leach, right? And it is as it is asking 1 hour, it is expected to complete at 10 a.m. But let's say at 9:30, a AR leach is arrived to the system. It is asking the resource from 9:30 to 10:30. Yes, because it is non-primitive based effort. If it is primitive based effort, we can preempt it and we can start A2 and after that we can resume best effort lease again. But as it is a non-primitive based effort, it will continue. It is not going to accept the AR lease. So AR lease is going to be rejected. Okay, this AR lease is going to be rejected. But if a AR lease is arrived to the system at 10 a.m., so 10 a.m. it is going to release the resources, right? So that AR lease you can again you can assign the resources because resources are free at 10 a.m. Okay, but the major problems with primitive based effort, not non-primitive based effort. Primitive based effort is that frequent preemption is avoided, right? Like if you are asking 1 hour resources, it may give the resources like 5 minutes, then let's say 10 minutes, okay, 20 minutes, right? Again 5 minutes, right? Again 10 minutes, like that, right? One preemption happened at 5 minutes. Next is 15 minutes. At 10 minutes means that after execution of your 15 minutes of your work, then again after 20 minutes, okay, again after 5 minutes, okay, again after 10 minutes, again you will complete your execution in next 10 minutes. So see how many times the same lease is printed. Okay, in order to avoid that, in order to avoid this preemption overhead, so non-primitive based effort was developed, right? So that once you start your execution, it may be delayed. Like instead of 9 a.m., you start at 11 a.m. There is no issue. But once you start, you cannot preempt the non-primitive based effort lease. Okay, is it clear? These three leases. Any doubt in these three leases? Any question in these three leases? Primitive based effort, non-primitive based effort, advanced reservation. Any question? Am I audible?
Yes, sir.
Yeah. Any question? Anyone? Okay. So we'll proceed for the next type of lease, that is called as deadline sensitive lease. It is also, you can say, it is a primitive, special case of primitive based effort, right? You know what is the difference between primitive based effort and non-primitive based effort. So this deadline sensitive lease is also an example of your uh, primitive based effort, right? But in what way it is different from primitive based effort? It has a deadline. Okay. So in a deadline sensitive lease, it is a type of lease that needs resource before the given deadline. For example, you will say, I need a 1 hour resources. Okay. Let's say the number of nodes is three. Number of three nodes is three. But you need to give me this 1 hour. Let's say I have submitted it, let's say 10:30 a.m. Okay. I need 1 hour slot before today, midnight. Okay. Anytime you give evening 5 to evening 6, let's say late evening 10 to 11. Anything is okay, but before today midnight, you have to provide it. So these are the requirements that are already there in our primitive based effort. So we have added only a deadline parameter. This is your deadline, right? Today midnight is a deadline. You have to provide the resources before the deadline, right? So it is primitive in nature, but there is a restriction to their printability. So what it says that the lease is printed if and only if, like suppose you have given the resource at 1 p.m. Okay, you have given uh, resources at 1 p.m. Let's say 1:30, you observe that another high priority lease is coming and you want to preempt it. 1 p.m. you started, 1:30 p.m. another high priority lease is coming into picture. So you want to preempt it, right? So before preemption, there is a condition that the lease is going to be preempted if and only if the lease manager assures that it will be completed before the deadline. So 1:30 you can preempt it, there is no issue, but lease manager will assure that it will be complete before the today midnight. Let's say it is given assurance, right? Again, the lease has started at 4 p.m. and at 4:15 p.m. again there is a preemption. Again, the lease manager has to give assurance that it will be completed before today midnight. Okay, let's say it has given resources at 6 p.m. and it has completed the rest 15 minutes. So here 15 minutes, here 15 minutes, here 30 minutes. So 1 hour is completed. Okay, so you can preempt, there is no issue, but assurance should be given that it will need to complete before deadline. So you can see 9 is the you can say the time, you can say arrival time of the deadline sensitive lease. 1 hour is nothing but the duration, or you can say execution time. Then 5 is the number of node. 1 is the execution type. So I told you 0 means execution type is it is primitive. Okay, so the 0 means non-primitive. 1 means primitive, and let's say 12 is the deadline. Okay, so 9 to 12, it is 3 hours, right? Within this 3 hour, you need 1 hour of time. So you may get the resource from 10 a.m. to 11 1, or you may get resources from 11 a.m. to 12 no. Okay, so we represent it by SCNTD. SCNT already we have defined in the case of advanced reservation list, that is start time, or you can say in this case it is arrival time. E is nothing but uh, execution time, n is nothing but the number of nodes, t is nothing but the execution type, and d is the deadline of the lease, right? So you can give any time. Okay, here I have shown the examples without any preemption, but this example shows with the preemption also we can fulfill the deadline, but lease manager need to assure it. Okay, So let us proceed to another lease that is called as immediate lease. Okay, it is more priority over the advance reservation lease also. Right, immediate lease has more priority over all type of leases. If it is more priority, note that there is more chances of not accepting this type of leases. Okay, that means more chances of rejection of this particular leases. So this type of lease may evolve in future into urgent lease, where right now really does mean right now. What it indicates, suppose a lease is arrived at 9 a.m., it needs to start at 9 a.m. So you can say in immediate lease case, the start time is equal to the arrival time. Okay, somebody arrived now, you have to immediately provide the resources. But in the case of previous lease, let's say the variants of best effort lease or the advanced reservation lease case, right? You don't have such restrictions. Like a advanced reservation lease arrived at 9 a.m., but it is asking the resource from 10 a.m. to 11 a.m. So you can see the arrival time is different from the start time. Best effort lease, let's say it is arrived at 9 a.m. And it need to be completed, let's say before today midnight. So the start time may be anything, right? Anytime, whenever the resource is available. But immediate lease is having a restrictions. That is, start time is equal to arrival time. Okay. For example, here you can see it has arrived here. Then it is asking immediately to provide the resources. If resource is available, then it will be provided. But if the resources is not there in the system, then it is going to be rejected. Okay. Now you may ask, what is the practical application of this thing, right? Why these leases are important? So there is a resource manager that you have to install in your system. Those who are using Linux platform, you can search for Hygia. This Hygia is a VM based, virtual machine based lease manager. It is open source. So it supports three different type of leases. One is advanced reservation, another is best effort, another is immediate. Okay. So a set of users, okay, a set of users has given their requirement either in AR mode or BE mode or immediate mode or any combination of these three modes, right? And you are given with a, let's say, 4 node cluster, or you can assume a 10 node cluster based upon your resource availability. Okay, or you can virtually create it. Okay, and you have to execute these leases into this cluster. And the performance matrices are how many leases you have accepted, number of leases accepted, number of leases rejected. That you have to calculate. So if your algorithm is accepting all the leases, but existing algorithms or those algorithms that are there in the literature, they are not accepting all the requests, then definitely your algorithm is better than the other algorithm. That's why if you look into this IGA Open Resource Manager, or if you install it, you can take the practical aspect of these leases. Okay. Now, sometimes this deadline sensitive lease is also called as a best effort with deadline. Okay. Both are same. The deadline sensitive lease and best effort with deadline. It is same, but it is not there in the you can say high resource manager. Okay, that's why they say it is coming soon. When we say the best effort, we really mean best effort, but be reasonable, right? Best effort means like sometimes in network we say best effort delivery. Okay, so we put our effort to deliver it before some time, right? We specify. We specially mention that within a particular period of time it should reach to the our receiver. So that's why we say it is a best effort delivery. So here also we are willing to wait for our resource, but we may need them before a deadline. Like you are sending a particular message, you are expecting that this message will be reached to your friend within a particular period of time. If not, it is within 1 minute, let it be 2 minutes, right? But it should be delivered at the earliest. Like here you can see, best effort lead says that as soon as the resource becomes available, it will be provided. But best effort with deadline says that as long as my lease does not start or end any later than the deadline. As you have specified a particular deadline, before that deadline, you have to complete it, right? So in order to complete before the deadline, you have to ensure that it has started prior to that, right? Suppose your deadline is 5 p.m. In order to complete that task, you require 1 hour. So you have to see at 4 p.m. whether the task is already started or not, or whether the lease has started or not. If you start at 4 p.m., then only you can complete by 5 p.m. Otherwise, it is not practically possible. That's why it says that as long as my lease does not start or end any later than the deadline. So if it is started, let's say at 4:30, you know it takes 1 hour, so it will violate your deadline. That's why it is important to know that before deadline, okay, if you can estimate what is the execution time, so before that particular deadline, it has started to meet the deadline. Okay, is it clear up to this or any question? Okay, then there is another lease. Also, some people work in this type of lease that is called as negotiated lease. Like whenever we go to a marketplace, also sometimes we do negotiation. Okay, the shopkeeper tells a one amount, we say one particular amount, then they reduce some amount, we increase some amount. Like that, there is a you can say a type of bargaining or negotiation happen between two different party, right? So like here also in it is true in the case of resource allocation, and also bargaining happen or the negotiation happens between the cloud service provider and consumer. Like I told you about advance reservation, right? You observe that the advance reservation lease arrived to your system, okay, and mm, you cannot provide the resources, okay. It is arrived at let's say 9:30, and you have seen that 9:30 you cannot start AR. Then you make a negotiation with that AR customer. Okay, you said that no need to worry, I can provide you if you slightly change your start time to 9:30 to let's say 10, right? Then only I can provide. And instead of paying me $10, you can pay $8. That is fine for me. Okay, so this is a negotiation between a provider as well as the consumer. So if our computational needs are flexible, okay, if you are flexible, then only you will do. If it is not flexible, then simply the AR lease is going to be rejected. So the lease manager may ask you, uh, uh, ask us that are sure about exactly at 2 p.m. Suppose you need resources exactly 2 p.m. Your lease manager is asking you exactly 2 p.m. or sometimes you can be a little bit flexible by saying, okay, afternoon you provide it. That's why it is written here that maybe the manager mean to say at some point this afternoon, right? It is not exactly at 2 p.m., but let's say sometimes in the afternoon, maybe 3 p.m., maybe 4 p.m. So manager maybe manager can say that maybe we cannot get this shiny AR we want at 2 p.m., but about how about I get twice of the resources. Suppose you asked for a one node resource, so your lease manager is going to provide you a two nodes resources, but instead of 2 p.m. you have to relax it. Okay, instead of 2 p.m. you have to relax the start time. Okay. Or if you have asked resources for the peak hour or on peak hour, it is going to provide twice the node in the off peak hour, because they know that in off peak hour nobody is going to use the resources. Resource availability is more. Okay. Sometimes they are also say that I even throw a discount and free air conditioning to your resources as well. Right. So we do some kind of negotiations. Like in this picture also you can see, initially the customer requested the cloud service provider to provide a one node cluster, one node from the cluster, and it is ready to pay dollar 100. But let's say lease manager analyzed and see that we cannot provide resources to that particular customer. Okay. So what lease manager did here, lease manager says that instead of 2 p.m., if you change it to 4 p.m., then I'll provide you the node, but instead of dollar 100, you pay me dollar 50. I'll give you 50% discount if you change it to 2 hours later. Okay, or just like I told you, at some point this afternoon instead of 2 p.m. Again, the lease manager has seen there are some important leases arrived to the system. It has again made one negotiation between the customer. It says that if you change it to 6 p.m., then instead of dollar 100, you can pay dollar 50, you can pay dollar 25. I'm fine with dollar 25, but you change it to 6 p.m. Okay, like that, it is again saying if you change it to let's say 9 p.m., instead of dollar 25, you pay me dollar 10. Sometimes it can say I'll provide you two notes with dollar 10. Okay, maybe this is your peak hour and this is your off peak hour. Right? Like that, the negotiations happen between the cloud service provider and the consumer in order to fix a particular price or fix a particular start time, right? But sometimes it is rigid, right? Like AR case, it is more rigid. Immediate case, it is more rigid, right? So the customer may not agree. So at that case, if the resource is not available, then you can reject such leases. There are some other leases also come into picture, which is not important. Still, I'm telling you so that you have a overall idea that how we can go for other type of leases. Like if you go for a best effort leases, okay, especially if you go for primitive best effort leases, so you can see that it is frequently printed. But how many times you can do the preemption? That we don't know. We don't have any limit. So when you go for the period reservation, you have such factor. Okay, we introduced a factor that how many times you can print, because you know if number of preemptions are more, then the overheads are also more. Okay, number of preemption if it is increased, then overhead is also increased. In order to avoid that, period reservation was developed. Period reservation is a kind of lease that needs resource period by period or slot by slot before the given deadline. Either you can specify the slots also. For example, you can say once I'll start the execution, let's say before 30 minutes, I will not print. Okay, even if a print request is coming, I am going to dishonor it. Right? So, in fact, you can say the period reservation is a flexible of the previous leases, and you can say take a combination of your advanced reservation list and non-primitive based effort. For example, you can see here, suppose you need 3 hours. Okay. So you can say the maximum number of preemption is 3. Okay. So 10 to 11, the lease is provided the resources. So it is 10 to 11, it looks like an advanced reservation. Okay. Then again, it has started from 1 in advanced reservation mode and it has continued up to 2 p.m. Another 1 hour. So for this 1 hour period, this period reservation looks like an advanced reservation lease. But it is not completed. It is not completed here. It is not completed here. It will get another chance to execute it between 4 to 5. Okay, so it has completed its execution at 5 p.m. So it is more flexible, right? So for a particular period of time, this period of time, you can see this 1 hour, this PR is same as your advance reservation. But once this slot is completed, this particular period of time, this time, then this is just like a non-primitive best effort. Okay, not primitive. You can say best effort, primitive best effort. Okay, it is actually completed a particular slot, so you can print it. You can again resume the work in later period of time. So you can say it is slotted primitive, which is a hybrid of both primitive and non-primitive nature of the leases. Okay. So that is another kind of lease which we can think by mixing one lease with another lease, or to create a hybrid lease into picture, right? Now we'll go for another type of lease that is called as token reservation. Okay. So this lease is a kind of lease that alerts the lease manager when the token is about to expire. Like I mentioned, 5 p.m. is the deadline. You know, the works needs minimum of 1 hour, then it need to complete, it need to start at 4 p.m. 1 hour is the time required to complete the work of that particular lease, and deadline is 5. So obviously 4 p.m. If you will not start at 4 p.m., then the lease is going to be rejected. So this lease is alerting the manager that the token is going to expire if you not start at 4 p.m. So like best effort, this is also primitive in nature. So in order to deal with this token reservation lease, this lease actually maintains 3 different parameters. First one is called as token issue time. Second one is your token expire time. Another is token alert time. Token issue time means once the request is reached to the cloud service provider, that is called as token issue time. Or you can say the arrival time of the lease manager. Okay. Another is called as token expiry time. So it is the time when the lease is expired. That it can be considered as a deadline. Token issue time is called as arrival time. Token expiry time is called as your deadline. Token alert time is the difference between token expiry time and the period is token expire time to token issue time. Maximum period that can be asked, that is token expire time minus token issue time. But in order to find the token alert time, it is the difference between this token expire time minus execution time. That is nothing but 4 p.m. Okay, let's say the lease has arrived at 1 p.m. 1 p.m. is your token issue time. Token expire time is 5 p.m. Token alert time is nothing but 4 p.m. That is nothing but 5 p.m. minus 1 hour is equal to 4 p.m. And the maximum period we can ask is 5 p.m. minus 1 p.m. That is 4 hours. Okay. But it will be again an immediate mode lease, not a token reservation lease. So we maintain these parameters like this in terms of a 5 tuple: token issue time, token expiry time, execution time, number of nodes, and type. Okay. So there are 3 cases may happen in token reservation lease. The first one is token reservation lease has completed before token alert time. Let us take the same example. 1 p.m. is our token issue time. Okay. Token expiry time is 5 p.m. Okay. Execution time is 1 hour. So token alert time is equal to 4 p.m. What it says here, the TR lease has completed before TAT. Before TAT means before 4 p.m. Before 4 p.m., you have completed your execution. Then your lease is completed. So the lease manager does not have any role. It is completed well in advance. So there is no issue, right? Now come to the second case. The lease has not started till TAT. TAT time is reached. Let's say 4 p.m. happened, right? We reached 4 p.m. but your token reservation lease has not started. So here the manager has two choices. What the manager will do? In the first choice, it will convert the token reservation lease to an immediate lease or AR lease. Okay, because you know immediate lease is immediately arrived and executed. AR has pre-booked the resources from the start time to end time. Right? Start time to end time. So either you convert your token reservation lease to an immediate lease or token reservation lease to your advanced reservation lease and provide the resources immediately. That is the third choice. Okay. Or if the number of nodes are not sufficient to start this token reservation list, so in the second choice, what you can do, you have to start the new resources. Either you collaborate with the other cloud service provider to get the resources, or you can start if there is some machines are in idle state or in the passive states or in switch off state. Immediately you have to start new resources or virtual machine to fulfill the demand of the customer. Okay, is your second choice. Okay, either you convert it and provide the resources, or you start the new resources. For example, you can see here the TR is suppose asking, let's say 2 hours. 1 hour you have given 11 a.m. to 12 noon. Another you will provide 4 p.m. to 5 p.m. So 5 p.m. is the deadline. Let's say it is completed. But here, let's say up to your age, it is asking 2 hours here, and deadline is 5 p.m. means 3 p.m. is your token arrival, sorry, token alert time. So till 3 p.m. this particular lease is not arrived. So what happened? You have a 5 node cluster. So you have to immediately start node 6 and start executing the token reservation lease. Okay, not only this time is important, but whatever time required to start a resource, whatever time required to take a decision, that also you need to add. 3 p.m. is not exactly 3 p.m. you are going to take a decision. Just taking decision, starting a nodes takes also time. Let's say it is taking alpha amount of time. So the token arrival, token alert time is nothing but that time, okay, which you have calculated already. That is TT minus E minus alpha. Okay. Let's say it is coming, let's say 255 or 250, something like that. So at that time, you have to make an alert so that it can successfully start at 3 p.m. so that it can fulfill the request at 5 p.m. Okay, so that is the second choice. Third choice is if a lease has partially completed before TAT. For example, let us take this example. You are asking 1 hour, let's say 30 minutes is already completed. Okay, before let's say 2 p.m. Now, what you have to do? 30 minutes is completed. You are left with another 30 minutes. So instead of this 4 p.m. is the token alert time, you will update the token alert time to 4:30 p.m. Okay, the manager has to update the TAT and place it according to the updated TAT. Right? So in this way, we manage 3 different cases in token reservation lease. Okay. Now coming to the next lease, that is called as a advertisement lease. Okay. So an advertisement lease announces the free periods that are associated with the resources. Like you can see here, I have taken a 5 node cluster, and some of the nodes over a period of time, they are reserved, right? And a few slots are vacant. So what I'll do, I'll advertise these leases, right? So if you advertise the free slots, the customer may choose whatever you have advertised. Based upon that, they can make a request. Okay, but the lease manager has to provide the resources, okay, which closely match the demands of the users, right? So if you closely provide those leases which are closely matched with now whatever leases are advertised, that will improve the resource utilization. Okay, like our computer system also, we are looking into how to improve the utilization rate. Utilization rate is close to 100, then definitely you can say your system is properly utilized. For example, here you can see uh, 2 nodes, 2 hour is free. So this is 2 nodes, node 4 and node 5. That is 11 a.m. to 1 p.m. There is also a 3 node is 3 from 1 p.m. to 3 p.m. Okay, and 1 node is free at 2 hours period. Now, suppose a customer actually require 1 node and 1 hour 30 minutes. So the requirement of a particular customer is you need 1 node for 1 hour 30 minutes. Okay. Okay. So, but there are 4 slots, as I said. This is first slot, this is your second slot, third slot. Okay, so 3 slots are there, not 4. This is the first one, this is your second one, and this is your third one. Right? So now tell me which one you will pick as a advertisement leech. Okay, which one you
Three,
will pick?
three.
You will pick 3 because why we are picking 3? Because 3 is the closest, fulfilling our closest requirement. Because it is 2 hour, it is also 2 hour, all are 2 hours only. But 1 hour 30 minutes, 1 node. So you will pick 3. So in operating system also, when you studied different page replacement algorithms, right? Sorry, not page replacement, memory management techniques. You know that memory is partitioned into some slots, and you have to make a request for the memory slot. Then you are checking which one is actually closely fit with that one, right? So in order to decide the period, so I consider here 3 different type of strategies. One is the first fit, another is best fit, another is worst fit. Okay. So if you go for best fit, obviously, as you said, it selects the period which closely fulfill the customer demand. Like the third advertisement lead is closely fit because it is 1 node and 2 hour period, and our requirement is 1 node, 1 hour 30 minutes. So if you go for best effort list, third will come into the picture. And if you go for the first one, you will choose the advertisement period, okay, that satisfies the customer's requirement. Okay, the first slot advertisement is that satisfy your requirement. So if you go to this particular case, then the first one also satisfy your period because the first advertisement period is for the 2 nodes and 2 hours period, but the customer requirement is 1 node, 1 hour 30 minutes. It is satisfied. So we are going to assign the first one in the case of first fit, right? Now, if you go for worst fit, okay, in worst fit case, what we are doing? Worst fit case. Worst fit case, you have to choose a period which is closely fulfill the customer demand, and the percentage of resource wastage is very less. So in the best fit, we are looking into that, right? So where the resource wastage is very less. But when you go for worst fit, we are choosing the largest period. And in some observations, you can see worst fit is sometimes performing better than the best fit, right? You cannot say that worst fit always performs bad in comparison to the best fit, right? It purely depends upon what are the different type of advertisement leads. Based upon that, you can see sometimes worst fit is better than the best fit. So it selects the largest period. The largest period is this one, right? If you can assume that in future the small requests are going to come into picture, So in that case, you can see worst fit is better. In future, suppose if you assume that large leases are going to come into picture, in that case, best fit is better. So we choose the largest period among all the advertisement leads. For example, here the second advertisement lead is for 3 nodes and a 2-hour period. Okay, so definitely, so you are going to assign the second slot, right? Second slot to the customer, right? So in this way, actually, the advertisement lead actually works. So if you go for the best fit strategy, this is the solution already said by Rujina. And if you go for best fit, worst fit, and first fit one, you will get different slots. Okay, so now let us see the last type of lead, which is there in the real-time system. If you have studied a subject called real-time system, in real-time system, there is a hard deadline and there is a soft deadline, right? For example, I'll give a assignment to you. I'll say the hard deadline is today midnight, right? And the soft deadline is let's say tomorrow morning 6 a.m., right? So you have little bit time in between hard deadline and the soft deadline. Or sometimes you can say soft deadline is given first, okay, and it is extended till the hard deadline. Okay. On the other hand, you can say hard deadline is given. Once you exceed the hard deadline, you will be penalized. Okay, you will be penalized, or you will be given some less credit, but still you can submit your work. So soft and hard deadline leads is a special type of negotiated leads that specifies two deadline of the leads. Okay, the aim of creating these different type of leads is to give more flexibility to the customer. On the other hand, provider wants that the resource utilization should be as maximum as possible. So if a lease is completed within the first deadline, okay, first deadline means it is your hard deadline, then customer pay the requisite amount to the lease manager. Suppose you have agreed to pay $100 and your lease manager has fulfilled your deadline, then you have to pay $100. But is because you can say there are so many high priority leases are arrived to the system. So your lease manager is not going to fulfill your first deadline. Let's say the first deadline is violated. Then, but your lease manager assure you to give resources or complete the execution before the second deadline. Okay, in that case, customer will pay a discounted price to the lease manager. We provide a discounted price to the lease manager. Okay, for example, instead of $100, you will pay $50. Okay, if the soft deadline is fulfilled. Okay. Now, however, these deadlines are fixed. Okay, these deadlines are actually fixed by the lease manager, and it must be accepted by the customer. For example, you can see this is a soft and hard deadline lease. You are given E and T, SD and SD and B. So E is your you can say execution time. Okay, E is the execution time, N is the number of nodes, T is the type, SD is your soft deadline, SD is your hard deadline, and B is nothing but your violation cost, or you can say penalty, right? Like in the SLA example also, we have seen that what is the effective cost? We are calculating the effective cost by considering two things. One is what is the total amount you have to pay, and what is the discounted amount. Okay, we have a table, right? In that table, we can analyze what is the service credit you need to calculate, and based upon that, you can calculate the effective price. Like that, here violation is nothing but a discount which is in between 0 to 1. If the violation is 0.5, that means it is 50% discount. Okay. If violation is 25%, then you will get 25%, means you have to pay 75%. Right? Like here you can see a soft hard deadline lease is given. Suppose you can say 3 p.m. is the soft deadline. You can consider both case. One soft deadline, or you can say normally it is a hard deadline. It is not a soft deadline. So you have to complete before 3 p.m. If it is not completed, then you can execute it till 5 p.m. Right? Okay. You can violate this particular deadline, but not this particular deadline. That is 5 p.m. Okay. So these are nothing but a different type of leases, right? So what are the leases we have studied? Can anybody tell? Tell me what are the leases you have studied? First one
Advanced
is
list, advanced
advanced
list,
reservation. Yeah.
and then we
Second is
have best effort list. In that
hmm,
we have primitable best effort list and non-primitable best effort list,
okay.
deadline sensitive list,
Yes.
immediate list, token reservation list, and we have negotiated list.
Token.
Uh,
Okay. Then negotiation. Okay.
yes, and then we have advertisement list.
Advertisement leads. Right. Then
Yes,
soft
best
deadline and
and
headline.
soft list.
Soft and hard deadline. Okay. So these are the leases we have studied, right? Now, if I ask you, design a cost model for these leases. What is cost model? Cost model means you have to determine which lease is more costly, which lease is less costly. Okay. Because you know AR lease is available for a specific period of time. B is not having a rigid start time. So they are flexible and B leases are put in a queue and it is going to be executed whenever the resources are becomes available. So obviously the cost of advance reservation lease is more or less. If I say cost of advance reservation lease and compare with the cost of best effort lease, which one is more costly? Which
AR
one is more
list,
costly? Which leads?
AR advanced.
AR leads, yes. Okay. But if I ask you probability of acceptance, let it be probability of acceptance of AR leads and probability of acceptance of B leads. Which one is more probable to accept? Best effort leads, right? Because if you are not giving a specific time, okay, you are more flexible. More flexible means chances of acceptance is more, right? So acceptance of AR lead is less probable and B lead is more probable as AR is specific time. Or you can say probability of, by looking into these two, you can say the probability of acceptance of the leads is inversely proportional to the cost incurred for the release. Right? Now, if I say you compare cost of immediate lease with cost of advance reservation lease, which one is more costly?
Immediate list.
Is immediate lease, because immediate lease is arrived to the lease manager at uh, any point of time. Okay, and it demands resource on its arrival. It will not wait for a 1 minute time also, right? So immediate lease is more expensive than advance reservation lease, right? But if I ask you the probability of immediate lease and probability of advance reservation lease, you will see AR lease is more probable to complete, right? Because there is a gap between arrival time and your start time. But immediate lease case both are same. So if you combine these two, so I can say it, probability of best effort is more, probability of advance reservation is next to probability of best effort, and probability of immediate lease, right? Similarly, cost of immediate lease is more in comparison to cost of advance reservation lease in comparison to cost of best effort lease. So these two we can infer from these two, right? Similarly, you can express other type of leases, find their relationships, right? You may get little bit confusion when you do this one, but mostly we are going to discuss advanced reservation, best effort, and deadline sensitive and immediate leads, right? So if I put a deadline sensitive, let us go for another one because these leases are not there in the Hygia resource manager, right? So if I calculate the cost, where I will place immediate deadline sensitive leads? Can anybody tell? First is immediate is going to come, right? Then cost of advanced reservation list, then I can put cost of deadline sensitive list, then cost of best effort list, right? Similarly, probability in the reverse direction, probability of best effort is more, probability of deadline sensitive is more, probability of advanced reservation is next to that, and probability of immediate list. Right? This sequence will get if you analyze the cost model. Now let us see what are the different toolkits are there. Like these cost models I have given in detail, so you must go through it. I'm not going to tell you detail. So these are the different toolkits or different cloud service provider. Some of the cloud service provider we know, like Amazon EC2. If you go for Amazon EC2, if you study their allocation policies, you will come to know they are using the best effort allocation policy, right? Nimbus is another cloud, so in which the allocation policy is only immediate. It is taking only one type of leads, not different variants of the leads. Similarly, if you go for Eucalyptus, is another popular cloud service provider. You can say it is a platform as a service where it is you can say it is its allocation policy is immediate, right? So you can see immediate is very stringent, right? But still, okay, people uses that particular allocation policies, right? Okay. The next one is you can say Open Nebula. They are using the best effort allocation policy. But when you go to for IGA Open Resource Manager, as I said, it is open source. And if you go for it, then it is immediate, best effort, and advanced rejection. All the three allocation policies are supported by IGA Resource Manager. Okay. So once you install this software, you will get more details related to these type of leases. Okay. So I'll show you how actually these leases look like. Just a minute. Let me show you a simple example so that you can understand how actually these leases are submitted by different user or customers. So let me share my screen again. Is it visible now? Let me reduce the font a little bit. Okay, you can see here my slide, right? This notepad file I'll share with you, which you can give input to your Hygia resource manager. And I have a different set of files. Like I have a file with you can say 13 leases, 23 leases, 33 leases, and 43 leases. Okay, you can create as many as leases as possible, but these are the simple file. Actually, these files are LWF files. These are not like you can say XML files, right? Which is in LWF format. You have to convert it into a structured file. Okay, it is a semi-structured file, and you have to convert it into a structured file, preferably in a notepad file or into a Microsoft Excel or to a comma separated value file, CSV file, and that you have to give input to your Hygia Open Resource Manager. So out of 13 leases, you have to tell me, right, how many leases are accepted out of 13, how many leases are accepted out of 23, 33, and 43. That is our aim. So let us understand actually what are the different, I mean, or you can say how a lease actually look like, right? And how to give different parameters in a particular lease, right? Or how customer submits a different type of leases to the cloud service provider. So these files are the XML files. Those who have already used XML, you know that we are writing XML version in the first line. Then here we have given the lease workload name as deadline 10, and the name may be anything. Then there is a description here to understand you that what are the different lease there in the system. So like here you can see first lease does not end prematurely. Okay, in fact, whenever the first lease is reached to the system, all the nodes are free. Okay, the nodes are completely free. So definitely it is not going to end prematurely. Second and third lease end prematurely, and second and third lease starts at this particular time. You can consider this is your let's say minute, and this is let's say hour and day, or something like that. You can assume, right? Some time frames are there given. Now you can see if you come down, this is the resource type. The resource type is CPU or memory. Number of node requirement is 4. Okay, the number of node requirement you have 4, and the CPU the amount required is 100. 100 means it is 100 MIPS, that is million instruction per second. Memory is 1024, so you can say 1024 MB. So these are the two different resources under our CPU memory, right? Okay. Next, these are the requirements, overall requirements. Now let us proceed to the first lease. Like here you can see a lease request is arrived at this particular time, where all the values, the time is set to 0. Okay. The lease ID is 1, primitive is true. Okay. Because it is a deadline sensitive lease. So you know in deadline sensitive lease, the primitive is always true. And the number of node requirement for the lease number ID 1, it is equal to 3. And resource amount required to execute this lease is 100. Resource amount required here is 1024. Right? And you can see the exact time, okay, where you have to start the resource is 0010. Okay, that means let's say 10-minute time, or you can say this is midnight 0. Then you can say at 0010 you can start the first lease. And the duration requested for the lease ID 1, it is 0040. That means 40 minutes it is asking. So if you start at 10, then it will complete by 0050, right? Because all the nodes are free, right? And deadline time is 0140. That means before 1 a.m. 40 minutes, you have to complete this particular lease. And each lease is associated with a disk image ID, that is foobar1.ing. Okay, and the size is 1024. Like we are creating image file, here also we are creating an image file. Okay, now coming to the second lease. Second lease is arrived at this particular period of time. You can see the difference between their arrival time and their start time. Okay. So, but if you go for immediate lease, you can see these two times are equal, right? And lease ID is 2. Like if you go for lease ID 1, it is asking you only 3 nodes. But here it is asking you 4 different nodes. And resource amount is 100. resource amount is 100 for CPU, is 100 MIPS, and for memory it is 512 MB. Okay, and the duration is 50 minute, you can say. So if it will start at node cluster. The earliest time it can start, it is nothing but 0050. Right, 0010 it is started, 0040 time is required. So 50, at 50 minutes it is going to complete. So 50 minutes we can start here, this one. It requires another 50. So it is just meeting the deadline. Right? That is 1 hour 40 minutes. Okay, like that you can see lease ID 3 is there, lease ID 4 is there. So if you see, you have around 13 leases here. Okay, first you sort them based upon their arrival time. Then you have to do hands-on calculation, as well as you have to write the code. Okay, or you can go through Hygia Resource Manager, because there is a default resource allocation policy is already there in Hygia Resource Manager. So you can give this file as input, and you can see how many leases are accepted by Hygia Resource Manager default policy and how many leases are rejected. Right? So like that, I'll share these other files also. Like you can see here, 23 leases are there, starting from lease ID 1 to we have lease ID 23. Okay. Similarly, 33 leases case, it is from lease ID 1. Okay, this is your lease ID 1 up to lease ID 33. Okay, and determine how many leases are accepted and how many leases are rejected. Here you have more details, that is lease ID 1 to lease ID 43. Okay, like that different set of files are given to you, and you have to see that out of these leases, how many leases you can accept through different resource allocation policies, right? So basically, I'll tell you about three different resource allocation policies. Okay, so that you have an idea about how actually these leases are assigned to a 4-node cluster or a 5-node cluster, which whatever given to you, right? So we'll discuss about the three different algorithm. First, we'll go for Hygia Resource Manager. Then we'll see one improvement over that Hygia Resource Manager algorithm, which is called as a DPS algorithm, and one improvement over the DPS algorithm that is called as Alert Time Based Resource Allocation (ALTRA). These are the three different algorithms that you have to focus and you try to implement, not necessarily in the Hygia Resource Manager, but also you can write a Python code, or you can write a C++ code, or any programming language you are comfortable, by taking these lease files as input, and so that how many leases are accepted in each and every file, how many leases are rejected in each and every file. So I'll tell you about one basic algorithm today. Rest algorithm we'll see in the next lecture. So this is the problem that is given to you. So you are given with a set of leases, where each lease is represented in the form of 6 tuples. Like I told you, a XML file is not a structured file; it is a semi-structured file, right? So once you want to process something, you have to convert a semi-structured file to a structured format, right? Convert the semi-structured file to a structured file, then you try to process them, right? Like our Excel file or CSV file, this structured file, right? It is more meaningful than the XML file. right? And the six tuple that you are maintaining for each and every lease, they are ID, arrival time. ID is your identification uh, number that is assigned to each and every lease, like we have seen 1, 2, 3, 4 order we are giving. And arrival time, S is your or ST is your start time, D is your deadline, P is nothing but the period after 12. Uh, Period. And N is nothing but the number of nodes. Okay, so these are the six different parameters we are maintaining. And first two parameters are actually ID and arrival time. When your lead is arrived to the system, that will be determined by your cloud service provider. And ID, like whenever you are launching instances or whenever you are creating a bucket, a specific ID is given to you. So these are the responsibility of the cloud service provider to give you the first two parameter, that is identification number and arrival time. And the rest four parameters are nothing but the lease requirement, like start time, or you can say deadline, period, and number of nodes. Right? This will be determined by the your customer. Right? Like I can specify I need a resource from 5 p.m. to for a period of 2 hours, and my deadline is, let's say, 5 a.m. Okay, and the number of nodes I require is 4. Okay, this requirement will be decided by your cloud service provider. Sorry, by the customer. Okay, not by the cloud service provider, but first two parameters are by the cloud provider. So given a set of M resources, not necessarily you are given with a 4 node, you can go for 10 node, you can go for 20 nodes based upon your resource availability. And you are given with a set of n leases, that is L1, L2 up to Ln. Nodes are represented from N1 to Nm. The problem of resource allocation is to map these leases to the resources such that your lease rejection ratio is minimized, or you can say lease acceptance ratio is maximized, right? Acceptance should be maximum, rejection should be as minimum as possible, right? Now, I am giving an example here. Like here, I have given a set of 7 different leases. Their arrival time is given, start time is given, deadline is given, uh, number of nodes is given, duration or period is given to you, right? And let's say these leases you want to map to a 4 available nodes, right? Assume that there are 4 node cluster is given to you. You have to map them into 4 node cluster. So each lease will be assigned to one or more nodes in any order. For example, it is asking 3 nodes. So I can give node 1, node 2, and node 3. Somebody will say that I'll assign node 2, node 3, node 4. Somebody can say I can assign node 1, node 3, node 4. Somebody can say N1, N2, N4. All are equally valid, right? So you can choose any 3 nodes. Not necessarily you are going to choose the nodes the in a particular order, but better to go for a particular order. But it is not compulsory, right? So order of the nodes assignment is completely immaterial whenever you are assigning these leases to the system, right? So here I am giving you a simple example with 7 leases, but you have to do it for 13 leases. You have to also do for 23 leases, 33 leases, and 43 leases. These are the files that are used in the resource allocation algorithm, but there is no hard and fast rule that you will follow this one. You can design your own leases by taking, let's say, 10, 20, 30, 50 leases, 100 leases, even if you can go for 1,000 leases also, right? Similarly, number of nodes is considered as 4, but you can go for as many as nodes are possible in your algorithm, right? So can anybody tell in what order you are going to assign them? In what order we need to process them, or in what order you can assign these leases to available nodes before discussing any resource allocation algorithm? What comes to your mind? If 7 leases are given to you, how you are going to assign these leases to in what order you are going to assign to 4 node cluster? In what order you need to process? Can anybody tell? Okay, one particular order you may suggest that we can process as per the arrival time. Okay, we'll go for arrival time. Yeah, Ronak mentioned first come first serve order. First come first serve also having two meaning here. Ronak, see here, like arrival time is given, right? Arrival times are in the increasing order. Sometimes the leases are given in any random order, but first you need to arrange them based upon the arrival time. That is one case if you go for first come first serve order. Somebody case that can say that why not the first come first serve order is the start time, because although the leaves or the leases are arrived to the system in FCFS order, you can maintain, but we are assigning the resources based upon the start time. Somebody will say that we will arrange the start time order, start time in the increasing order, and when there is a conflict, like you can see the first 4 leases are require resources at 9 a.m., then we can break this conflict by considering the arrival time, right? Like there is a tie between the first 4 leases, so we look into their arrival time to arrange them in a particular order, right? So FCFS may be applicable to the arrival time, FCFS may be applicable to your start time. But when there is a conflict, you can go for the arrival time. So different way you can think, right? So now I'll tell you a very simple calculations. Like I am taking a 4 node cluster here. Okay, let's say this is my 4 node cluster. Each and every row represents the node, right? So first node, let's say I'm representing here as node 1, node 2, node 3, and node 4. I'll tell a normal algorithm. I'm not going to any allocation strategy. Next class, I will tell you in much details. So first node require 9 a.m. Let's say this is 9 a.m. So L1 is asking in between 9 a.m. to 10:30. Okay, 9 a.m. is the start time, 10:30 is the deadline. It requires a 40 node slot, okay, of one node. So I am giving a 40 node slot here. Okay, I can say this is L1, and let's say this time is 9:40 a.m. Right? Next, L2 is asking again in the same start time and same deadline. It is asking a 30 uh, minute slot for 3 different nodes, right? So you can say, sir, we can assign here, right? 9 to 9:30 a.m. I'm giving 3 node to L2. So I can write here L2, right? So next is L3 is asking me in between 9 to 10:40. It is asking 30 minute, but 2 node one, right? 2 node number of nodes is 2. So I can start after 9:30 only. Before 9:30 it is not possible. So it is taking 30 minutes, but it requires 2 nodes. So it will complete by, let's say, if it is starting at 9:30, it will complete at 10 a.m. And I'm giving a 2 node slot here. This is your L3, right? Now L4 is asking me in between 9 to 10:30. It is asking a 40 node, 40 minute slot for 4 nodes, right? So you know before 10, let it be dotted one, right? So before 10, you cannot provide 4 nodes. Is it possible to provide 4 nodes before 10 a.m.? Can anybody tell?
No.
Is it? No, right? Because you know that up to 9:30, all the 4 nodes are occupied. Even if after 9:30, you can see 2 nodes are at least occupied by L3, and 9:30 to 9:40, one more node is occupied by L1. So simply what you can do, L4 you can be rejected, right? We cannot assign it. Then again, you can say in between 10 to 11, right? In between 10 to 11, we need a 40 nodes for 10 minutes slot. Okay, we can provide it. You can say this is up to 10:10 a.m. I am providing one node to L5, right? Similarly, if you go for L6, L6 is also asking from 10 to 10:50, a 30 minute slot. Okay, if I assign a 30-minute slot for one node only, so I can, if I start at 10, it will go up to, let's say, 10:30. Let it be 10:30, and this is one node slot. I can say this is L6, right? So 10 to 10:50, I'm assigning a 30-minute slot. It is meeting the deadline. Then L7 case, it is asking from 10:30 to 11, 3 nodes. Yes, after 10:30, all the nodes are free. So I can assign the first 3 nodes so that it will complete 20. It is asking 20 minutes, right? 20 minutes means it will complete at 10:50 a.m. I can assign these nodes to L7. Okay. So how many leases we have accepted here?
6.
Yeah, we have accepted 6 leases, and we have rejected 1 lease, that is L4. Okay, that's why I told you I'll not discuss about the resource allocation policies today. So now there is a challenge for you. You can take a snapshot of this particular slide and apply your skill to alert all the 7 leases, because you already have an answer, that is 6 and 1, right? 6 is number of leases accepted, and number of leases rejected is 1, right? So it is better that you try any hit and trial method, or you apply your any technology to assign these leases in such a manner that all the 7 leases are going to be accepted and no leases is going to be rejected. Okay, so better you take a snapshot of this slide and try this one. In the next class, I'll ask you your answer whether you are able to assign all the 7 leases to the system or not, and what method you have used uh, so that the number of leases accepted is 7. Okay, so we'll stop here, and we'll discuss the solutions, and whatever existing solutions and whatever solutions you can suggest in the next lecture.